1.805. Now here is Z. This is for those who are using this. You do this if you are using the Z distribution. If you are using your calculator, all what you need is to find sigma x bar, which is 3.2 over 6, over square root of 36, which I'm calling it 6. This is the new standard deviation. If you are using Excel, you can use this directly. Can somebody tell me what this is? It shouldn't be 1.87. It's 1 over that. 0.5333. 0.5333. So we can use Excel here. If we are using Excel, we will say equal to normal distribution. And we have 11. I can just write 11, 12. The mean is 12. The standard deviation is 0.533. True. Normal, 11, 12. The second 12 is for the mean. Okay, I added this 11, 12. This will give us the left side and 0.533. So you subtract this from 1. I'm sorry, from 0.5. So that is one way of doing it, by using Excel. I thought has anyone tried to use Excel? Anybody using Excel here? Mm-hmm. For which number? Let's use Excel for 21. So which one do you want to do? 21A. So what is the quotient for that 21A? You want to find the probability that? What is the mean? The standard deviation? 1.6. And we say x is what? So you want x to be less than, x is less than 8.2. So you will have equal to normal, because it is less than, you just use it directly. 8.2, the mean 8.9, the standard deviation 1.6. So it's good to be practicing if you intend to use Excel, so that when you get it wrong, I will correct it and you will learn how to use it. So what does B say? So this was A. Please, I'll observe that this one is now x less than 8.2. That's the difference between A and B. X bar with n equals to what? 10. So when you do that, you want to find so we want to, A was probability that x is less than 0.2. E is probability that x bar is less than 0.2. In handling x bar, we need to know the sample size. So with this, we are going to find the standard deviation for the sample mean. The standard deviation for the sample mean is the standard deviation of the population divided by square root of n. So this becomes, standard deviation is 1.6 divided by root of 10.
Not 0.5
0.506. So now we are going to use the mean is 8.9 and the standard deviation is 0.506. We use it on Excel and we see equal to normal 8.2, 8.9, 0.506. So that's the answer for, was it C? It's B, 0.83. So when you have a regular value, that is a value is selected at random, you use X. Find the probability that the mean is. For the mean, you need the sample size. And you change the standard deviation. Any other question? Anybody else has a homework question? So we started chapter 7 last time, right? Did we finish 7.1? Margin of error, we did margin of error. We are going to do it again today anyway. So essentially, what we did not do is the minimum sample size. Margin of error is E if sigma is none. The margin of error is E equals to Z alpha over 2 times sigma divided by square root of n. Do we remember that? The margin of error is Z alpha over 2 times sigma divided by square root of n. And the confidence interval is x bar minus E. Let's look at some examples. A researcher wishes to estimate the number of days it takes an automobile dealer to sell a Chevrolet. We did that last time, but we can do it again. A sample of 50 cars had a mean time on the dealer's lot of 54 days. Assume the population standard deviation of the population to be 6 days. Find the best point estimate of the population mean and the 95% confidence interval of the population mean. What is the best point estimate of the population mean? The sample mean. So let's get back to anyway. Our whiteboard. We need to know what is the sample mean, what is the sample size, what is the population standard deviation. To compute the confidence interval, we need this and the confidence level. So let me write it here because I cannot have both at the same time. The mean is, the sample mean. Sample mean. Okay, what is the sample size? What is the sample size? 50. Now sample mean, 54. Population standard deviation. And the confidence level? 0.95. With 0.95, Z alpha over 2 equals to 1.96. So we are going to, here is 54.
56.95. So Z alpha over 2, 1.96. E is equals to Z alpha over 2 times sigma over square root of n, which is 1.96 times 6 divided by square root of 50. You can use your manual calculator, yes, regular calculator to do this. Would you want to learn how to use your TI-83 calculator to do this? Would you, anybody, you have your calculator? Anybody else have a calculator? You have it? Okay, you have the answer to this E? Okay, what is E? 1.7. So we can all get this, can we? If we have this information. So the confidence interval is X bar minus E less than or equals to mu less than or equals to X bar, which is 54 minus 1.7. So this is 54 minus 1.7 is what? So this is how we find the confidence interval for the mean if sigma is none. If sigma is none. Don't mind the rounding up in your textbook. It depends on each context. So there's no general rule for rounding up. This is the average time it takes to sell a car. Instead of writing 52.3, you can just write 52 years. And so sometimes you will have the question of finding the minimum sample size. The margin of error is the maximum error of estimates. For example, I may say, I would like to know the average salaries of workers in this county, but get enough sample so that the point estimate you get from it should not depart too much from the actual average, which we don't know. So that is what we call the margin of error. It's the maximum error of the estimate. So if you have the margin of error, you can use it to find the minimum sample size using the formula we have on the board, which I'm going to write now, but I want to explain first before we do the example. Let's look at the example we have. A scientist wishes to estimate the average depth of a river. He wants to be 99% confident that the estimate is accurate within 2 feet. From a previous study, the standard deviation of the depth measured was 4.38. What is the minimum number of times he should measure? This is like when you are measuring the depth of a river, the measure is not the same all the time because the river is not stable. So you need to take a certain number of measures and take the average. And even what you get as average, we know is not the exact depth. Just as I say about weather. When you get weather forecast, it is given to you as a confidence interval. They will say the minimum will be 52 and the maximum will be 58. Sometimes you get 51, sometimes you get 55, sometimes you get 62. That is, sometimes it is within or out. But sometimes you may want them to be as accurate as possible, depending on what you want to do with that information. And you might say that if you give me an estimate that is within 3 degrees, that will make sense to me. I will use it. Otherwise, I will not use. To make that estimate within 3 degrees, meaning that the error from the actual value should not be more than 3 degrees, then 3 degrees is the margin of error. So if we have the margin of error, we can use it to find the number of measure you can take. That is the sample size, the minimum sample size. So in this example, we want to record that what is the margin of error here. What is the margin of error? 2. We want that the estimate is accurate within 2 feet. So E equals to 2. The confidence level is 0.99. And the standard deviation of the population is 1.38. So we are going to use this to find a E equals to 2. Confidence level 0.99. Just by this, we have 0.58. You get this from the table. You get it from, I gave you for 90, 95, 99. Those are the most common ones. And then sigma is equals to 4.38. So N is Z alpha over 2 sigma over E squared, which is 2.58 times 4.38 divided by 2 square. Can you use your calculator to find this? You do 2.58 times 4.38 divided by 2, and then you square it. Don't forget to square it. So what do we have here? 31.9. So we will round it up to, for sample size, always round it up. That's the minimum sample size. Now we want to look at the confidence interval. So far, sigma was none. Now, if sigma is not known, we are going to use the t distribution. We are going to do essentially the same thing with another type of distribution called the t distribution. It's a distribution that looks like the standard normal distribution, but because it is bell-shaped, it is symmetric about the mean. The mean, the median, and the mode are all the same and equal to 0. The curve never touches the x-axis. And the variance is greater than 1, unlike in the standard normal distribution. The variance is 1 for a t distribution. It depends on the sample size through what we call degrees of freedom. So to use the t distribution, you want to know what is the sample size and use it to determine the degree of freedom, which is n minus 1. So the larger the sample size, the closer the t distribution will be to the z distribution. So as you see here, the degree of freedom is n minus 1. We are going to use that degree of freedom to find t alpha over 2. So here, E is equal to t alpha over 2, s over square root of n. So degree of freedom equal to n minus 1. So next, let's learn how to read the t distribution, identify the t alpha over 2. So this is how a t distribution table will look like. You can find a table in your textbook. You have this formula sheet. The first table is the normal distribution. First and second, normal distribution. The third one is the t distribution. If you don't more have this, you can get it at the back of your book here. So if you have your table, you can look at it. We can look at it together. And let's do at the same time an example. This example is find the t alpha over 2 value for a 95% confidence interval when the sample size is 22. When the sample size is 22, the degree of freedom is what? N equals to 22. The degree of freedom will be what? Now C equals to 0.95. So if you look at the table, the t distribution table, you will see the confidence interval. The first row is confidence interval. This is it here. This is exactly what you will see on your table. So we will identify the confidence level here, and then move to the degree of freedom here to get t alpha over 2. What is t alpha over 2? .08. And we all see it. You need your table, which is in your book. You can Google for t distribution table, but the problem with the t distribution table is that they are of many types. So we will focus on this one, which is here. Let's look at this example. 10 randomly selected people were asked how long they slept at night. The mean time was 7.1 hours, and the standard deviation was 0.78 hours. When you see a problem like this, it means that 0.78 is the sample standard deviation. So when you are not told what distribution to use, you can look at the problem and see if the population standard deviation is provided. If it is provided, you use the Z distribution, Z alpha over 2. For 90, 1.65. For 95, 1.96. For 99, 2.58. If you are not given the population standard deviation, you use the T distribution, depending on the degree of freedom. Let's record the information we have here. What is the sample mean? 7.1. Sample standard deviation, 0.78. Sample size. Sample size, 10. Confidence level, 0.95. So, for n equals to 10, what will be the degree of freedom? 9. So we will use it to find T alpha. Use your table, please. Let me look for a table here. T distribution. They have a T distribution calculator, but you will be confused to learn about that one. T. This is a T distribution table. I want to make sure that so this we have 95 and degree of freedom of 9. What do you get? Have you read from your own table? What do you have? This is not the same as this one. 2.262 is the next. This is this one. So what is happening here? Here, yes. Yeah, you are feeling that there is something like there, right? So this one is dividing the 5% into 2. So here, for 95, sometimes that's why I say just focus on your own table. So let's use just one table, because everybody has his own table and explain what it means. So when we say 95, the middle is 95. So from one tail you have 0.025 and the other one 0.025. So the cumulative to the left is 0.975. So from you are going to look for T of 0.975. So let's forget about this. I was trying to get one, just for you to know that you don't just get any table. You need to understand the table to know what the table is telling you.
So we have C alpha over 2 equals to 2.262. So you fit it into the equation as we did before to find E. So here, E equals to T alpha over 2 S over square root of n, which is 2.262. S was 0.78 root of 10. So we will get 0.056. You can try that using your calculator. Use your calculator, you will have 0. Is it 311? Do 2.262 times 0.78 divide by square root of 10. Square. No. Okay, what you should do is, to avoid mistake, what is square root of 10? Separate your operation, because using calculator can be tricky sometimes. What is square root of 10? 3.16. Now you want to say E equals to 2.262 times 0.78 divided by 3.16. So what do we get? .56. So it's better to do the square root separate. Now we subtract it from the mean, 7.1 to get 6.54. Adding to the mean, 7.1 to get 7.66. So the confidence interval is 6.54 to 7.66. So the confidence interval is 7.1 minus 0.56. (7.1 minus 0.56 is what? So we have the confidence interval for the mean when this is another example. Sometimes you may have data values. So the data represent the sample of the number of whom fire started by candles for the past several years. Find a 99% confidence interval for the mean number of whom fires started by candle each year. How many values do we have here? N equals to 7. C equals to 0.99. And Degree of freedom, 6. So what is T alpha over 2? Look at the table. $3.707. Now you can use Excel to find the mean and the standard deviation. The sample mean will be 7041.4. You can use either your calculator or Excel. And the standard deviation is 1610.3. E will be T alpha over 2, 3.707 times S, 1610.3, divided by square root of 7. So here we have n equal to 7, T equal to 0.99, degree of freedom equal to 6, T alpha over 2 equals to 3.707. Sample mean 74.1.4. Sample standard deviation 1610.3. You get these values by using any mean that you use in chapter 3 to find the sample mean and the sample standard deviation. And now E is T alpha over 2 S over square root of n, which is 3.707 1610 divided by square root of 7. Has anyone compute the E? $225. Has anyone tried to compute it? The same thing? Okay. So we subtract it from the mean, add it to the mean to find the confidence interval for the mean. So far, we will observe that to find the confidence interval, we need to know what the margin of error is. Once you get the margin of error, subtract it, add it to the mean, and you get the confidence interval. In 7.3, we are going to learn how to find the confidence interval and the sample size for proportion. We will do just the confidence interval today. We will learn the sample size next Tuesday. So the sample mean is the number of success divided by the sample size. I hope we are not too slow. Do you feel we are too slow? Just average, right? But not too fast. So what we call the sample proportion is like
What is the proportion of female over male? You count the number of people and you count the number of female, divide. That's what we call proportion. So, sample proportion. Let X be the number of success. What I call number of success is the number of people satisfying a certain characteristic. For example, the number of people that have a certain disease, the number of people that feature some qualities, that is what we will be calling success. The sample proportion is P hat equals to X over N. And Q hat is 1 minus P hat. So the sample proportion the distribution of sample proportion as mean the population proportion. So what I'm saying here is that if the probability of success is P, the probability of success is P, then E of P hat is equals to P. P is like mu, P hat like X bar. So the expected value of the sample proportion is the population proportion, which is the probability of success. And the variance of P hat is PQ over N. So the standard deviation of P hat is square root of PQ over N. So P hat is a distribution with mean P, the probability of success, and standard deviation square root of PQ over N. We are now going to say that if NP is greater than or equal to 5 and NQ is greater than or equal to 5, remember in 6.5, that's what we said. Then P hat is approximately normal. And this margin of error for the confidence interval for proportion is E equals to Z alpha over 2 times square root of PQ over N. We'll use P hat as an estimate of P to do that. Z alpha over 2 is the same as for the mean, for the Z distribution. So for a confidence level of 90, Z alpha over 2 is 1.65. For 95, 1.96. For 99, 2.58. You can always find it in the PowerPoint or in your book. Let's do an example. In a recent survey of 150 households, 54 had central air conditioning. Find P hat and Q hat, where P hat is the proportion of households that have central air conditioning. And we all find P hat, 54 out of 150. P hat is X over N. So I just want to make sure that if you have a problem involving proportion, you should be able to find the sample proportion. Number of success divided by number of trials. Okay. Let's do another example. A sample of 500 nursing applications includes 60 from men. Find the 90% confidence interval of the two proportions of men who apply to the nursing program. First, what will be the sample proportion? Here, n equals to 500. And what is x? 60. Look, we said that p hat is equal to x over n. To determine if this sampling distribution of sample proportion is normal, we want n times p. So x equals to n times p hat, which is 60. So once this 60 is bigger than 5, you just want to subtract it from n to see if what is left is bigger than 5, and you are good to use the Z distribution. NP hat is equal to 60, and Q hat is equal to 500 minus 60. 450. Both are greater than or equal to 5. Now P hat is 60 over 500. What is 60 over 500? 0.12. And what should be Q hat? 0.88. So the standard error of estimates for P hat, which is square root of P hat, Q hat over N, is square root of 0.12 and 0.88 divided by . So you do 0.12 times 0.88 divided by 500 and find the answer.
and take the square root.
And somebody gave me 0.12 times 0.88 divided by 500.
Point zero 0.145. Is it 0.0 or? 0.01. Okay, 0.014. Now when we take the square root, did you take the square root or is it already? Yeah, okay. So sometimes to avoid mistake, you want to do it first and then put it in the square root. So we will say here is 0.0145. E will be here C equals to 0.9. Z alpha over 2, 1.65. Z will be Z alpha over 5, Z alpha over 2, square root of P hat, Q hat. Yes. The Z alpha over 2.
Like, how did it become 1.65?
For 90% is 1.65. It's always like that. So you can look at you can. It's not. Don't really go to Z alpha over 2. Just take it all as Z, maybe like Z alpha over 2, like one thing. You don't need to work that alpha over 2. It will be more confusing. So yes, you have it in the PowerPoint. You have it in your textbook. But I can give you the most common ones. I'm going to lose power here. The most common ones are C, Z alpha over 2. If C is 90, 1.65. If C is 95, 1.96. If C is 98, 2.33. And if C is 99, 2.58. You would have noticed that we have been using those numbers. This is 3, 3. 98 is not commonly used, but sometimes you can see it. At this point, this is the best way for you to recall it. But if you really want to understand it, for 90, the tail is 0.05. We divide 10 by 2 and take it transform into percentage. For 95, 5% divided by 2, 0.25. Just take left tail 0.25% and you will get the Z alpha over 2. So this is over 500 over n, which is 1.65 and 0.0146. And what is this? 0.024. 0.0. So we are going to subtract it from 0.12, add it to 0.12. You get the confidence interval for the mean. Okay.